So, hello, my name is Yulia Romanchuk, and today I will be presenting my project. And the main guidelines for this project is to analyze the ability data for clusters and then analyze the clusters to see what type of customers they are based on demographic, ability data, and policy data. Then create an analysis for quoted total payment to determine the most important features and then to predict the right amount to quote future customers. Identify a type of target variable that you feel gives an indication of risk to a general and use that target variable to model a yes or a no type of decision. So, first of all, we have to import all necessary libraries, some of the basic libraries and machine learning libraries. Then we need to be able to, since we have so many columns and rows, we are in need to be actually able to read all of that columns and rows. So we have to import that option as well. So first of all, we have to import all the data sets of our phase 2, and here's the links for it, and here's our import. So first thing that we want to do is prepare the data for Abilitech 2. And first thing is to check the information about the data set and see if we have any data types that are not suitable for our clustering. And we can see that we have the object over here. So we have to exclude the object type from the columns. And here we are, we excluded the object type column and we are left with float and integer columns, and we are ready to move on and prepare our data a little bit more. So let's see, what else do we have? It looks like we have these two numbers that are not gonna tell us anything when we're gonna be doing clusters. So if this amount go up, it's not gonna help us. So we have to get rid of the zip code and ACX zip 4. So we're dropping these columns and checking the data, and it looks like it has a lot columns. So let's see what columns do we have here to be able to see which exactly we want to import into our data set and actually use. So as you can see, there is a bunch of different columns, and I think we're just gonna use some of the main ones. And I think I would be using mostly financial data to see because I think it's going to be the most accurate when it comes to this. So we have to pull all names columns of ability data into new data frame, which shows only the names of the column. So that's how it's actually used. Now we have to create some of the list for columns that start with only have used, credit card for, have personal or joint, household owned. So that's the column that I actually selected to be my main data columns for my clustering. So now, after I selected all of these different data frames with all columns that starts with this, I have to concatenate all of the names of the columns, actually the columns, not just names, and select all the columns from Abilitech data. So now I need to concatenate the ability contact ID in selected ability data. So we did added the ability contact ID. And now I see that we still have some null values. So before doing clustering, we of course want to get rid of it. So let's just um, um, drop the ability contact data first, because this column doesn't mean anything when you're doing clustering, and this is object first of all, so we need to get rid of it. So then we're gonna drop all our null values. So we have clean data. Here's how it looks like, and it looks good. Okay, so now we are doing our cluster analysis. So first of all, we have to run our inertia model using range from 1 to 15 to see how many clusters are ideal in our situation. And after running this cluster analysis, I would say that our ideal is 4. So I decided to use 4 as my number of clusters. So we are setting the number of clusters, which is even to 4, and I added the random state to this line because I want my cluster always showing the same result. Because like when you run the clustering and you don't include the random state, it's not gonna give you the same results on all the time. So now I just added the random state to be able to set that default, let's say that way. So now we fit in the model, and we are creating this data frame for our labels, and adding that label columns with our predictions at the very end. So it's gonna take forever, so let me just scroll like that. Okay, and now we can see our cluster column that we added to our original data. So now I can see that my cluster number 1 is the biggest amount of counts for that specific cluster. So let's go ahead and see our overall statistic, because we want to describe our main customer, and we basically want to know what type of people are our usual customers and try to do targeting as far as the products, as far as the marketing and stuff like that, to focus on that specific customer. So let's see all the averages and means for to see some correlation in all of these clusters. So I went through data and I looked, and it looks like some of the columns that indicates that they have used credit card. Cluster number 1 is the highest mean number, meaning our average customer use credit card very often. We can offer some special for credit card user, like maybe setting automated payment and set discount on the policy. Like when you pay, let's say for full policy for like 6 months or a year, you have the discount if you use your credit card. Maybe do a special with a bank if they make some sort of discount or cashback for their users in deal cashback deals. So like maybe do some collaboration with the banks and acquire new customers that way. So I also looked at the have personal or joint home mortgage or loan, refinance, equity loan, which means our main customers, our main customer has or own a home, and we can target that group on upselling home insurance, let's say. Um, um, and that would be a good way to bring our lifetime value of our customers up. So, by looking at the data, have paid bills by different ways, we can assume that our average customer is not very digitalized. Maybe we can target those people not with just the regular emails, but with letters or some specials in newspapers, magazine, because it looks like they do read a lot of paper press. And also, uh, looks like they also have contributed to some charities, and this cluster number one is the highest. Maybe we can do a campaign that some of the part of percentage of the resources from policies will be donated to some charities. So maybe it's gonna give us more bigger amount of these clients, as they do love to contribute to charities. Um, Looks like uh, they like also, by looking at this group, I might assume, but it would be better to see if we can add the age category to this data. But it looks like this category are older because they like to go to the bank. They like to do the banking through the phone, not on the app. Um, they actually looks like they love to invest, and they are very financially intelligent, stable. Probably they have a higher salary, so we can add that data also to check to see what our target audience is. So this group looks like it's very loyal group of customers, as they tend to stay with their provider. When I checked the data, about tend to switch the cards, tend to switch the provider. It looks like they were the most stable customers. So this group also often has the business cards. So as they have the biggest amount of business card in this field, so technically they should own a business. So maybe we can come up with some business insurance deals for to increase again our lifetime value of the customers. So I think this group loves in-person experience, because when I went to the data through the data, um, that indicates that they like to do their taxes with the accountant, not through any of the application, not through online. They like to come to facility and talk to real people. That's the first one. Second one, they do love to come to the bank to do their deposits, to do their to put money, to take money out, to have their questions answered. So I think this group really love in-person experience. So usually the insurance company, they do not have that many actual physical locations. So I think it would be good maybe to open couple location where people can come and customers have the customer service support from in-person communication. As I said, per data looks like they trust providers more that way. Okay, so let's go ahead and move to predicting our quoted total payment. So first of all, we have to merge our ability data and master code on a column ability contact ID. Then we need to drop all null values from master code ability data and exclude float and integer column and check the type of the column, which is an object. So we see we have 14 columns that are objects. Some of this we will drop, and some of this we're going to use the label encoder and change them to numbers because we do not want any objects in our data. So first of all, we will drop the dates from the quote initial time, and because that's quote initial time, term effective dates, term expiration date, we do not need datas because as the numbers go up, they do not mean anything in our prediction. So we need to get rid of the time and date. After we did that, we are going to use our label encoder to transfer our objects to numbers. And here's the columns that we did that to. Okay, so let's see. Just want to make sure that we have all done. Yes, it all transferred to numbers. Okay, so now we are looking, we only have floats and integers. So we did clean the data, everything looks good, and we're ready to select our features and labels from master quote ability data. So first of all, we have to define our x and y variables. Our master quoted total payment will be the y, and everything else besides the my quoted total payment will be x. So first we have a random function to find the best alpha value to use, and after running this, we can tell that after 5 it start dropping. So like the best value of alpha is 5. So now using lasso, we're gonna run lasso model and select our alpha score, which is 5, and see what our accuracy and what our mean squared error. So accuracy is 47, which is really good, to be honest, but could be better. So here's we see that's our predicted train values and our test values. So now we need to make a data frame by lasso coefficient with most important feature names. So now we ran that, and we can see our top 10 features that matters the most. So in order to predict the most correctly, and in order to have the information that we really need, we need all these 10 columns. Maybe we might need only like 5 of them, because it looks like this top 5 would give us the most accurate. They're the most important in this data. So now we can see that the most important features that we have to take into consideration when quoting policy amount are driver active, meaning who is actually driving the car, main person on the policy, or additional drivers. So if it's main driver mostly drives the car, the policy will go up. Policy term, that's the second one. This tell us how long are they buying policy with us for. So the longer the policy, the lower the amount. Third, named insured driver points is very important to take into consideration. Again, the bigger amount, the higher is the premium. Number 4, driver count. So the bigger the amount, the higher is the policy, meaning how many drivers you have on specific policy. Um, Named assured marital status. I did notice the tendency that married people would pay less. Okay, so now we have to do modeling for policy risks, meaning we have to answer yes or no. Um, First, we have to merge our Abilitech data and the general on Abilitech contact ID. Then we have to merge the general Abilitech and claim transaction on policy number, drop all the null values and exclude floats again, not floats, objects. Transfer some of the object columns into numbers by doing a label encoder, and looks like we have all done, so it's ready to do the prediction. So first we have to check the correlation of the general Abilitech and select the strong features and then use random forest classifier. I know usually I would use logistic regression first, but I just decided to do random forest classifier this time. To see if it's going to be any different. So first of all, we have to split the data into feature and target variable. So our target variable will be the claim status, meaning we want to know if specific person will claim will file a claim or not. So our Y is claim status and our X is everything else besides the claim status. So we're running our forest classifier and feed our model, and then we predict our model. So our score is very high, which is 97%, technically 98, which is really, really good. But we have to check our confusion matrix and classification report to make sure that we have true positive and true negative really high. So here's creating our column with the predictions and now running our classification report and confusion matrix, and we can see that we actually have a really good score. It's 98%, and our values are really good for 0, but not so good for 1. So that might be explained with lower amount of our yes, which is really, really low compared to yes. So like that might be the reason why it's predicting low number. But maybe from random forest classifier, we actually achieved 98% accuracy, which is so good. So the correct prediction is 2,633, and only 56 predictions are wrong. So as you know that we use random forest classify in this case to determine the risk. So we selected our target variable, which is claim status, to know if the person will file claim or not. So I want to see if logistic regression will give us better results. So I'm creating logistic regression, and it's again giving me pretty much the same score. Adding our predictions, and here we can see that the logistic regression give us 98% as well, but it gave us a little bit better results. So both logistic regression and random forest is giving us 90% of accuracy, but we will select logistic regression because it's giving us less type 2 errors.